So now that you know conceptually what limiting reactants, excess reactants, and theoretical yields are, I'm going to teach you how to mathematically calculate the theoretical yield, which is a numerical answer, using dimensional analysis. And after you calculate theoretical yield, how to identify the limiting reactant based on your theoretical yield. Okay, so these are all the different steps you have to follow. It's not really complicated. It's just telling you how do you identify a limiting reactant problem, and then how do you figure out the theoretical yield. Okay, most of this is just telling you to do a mass to mass calculation. So I put all the steps here because we can read them as we are doing recalculation. Okay, so here's the problem. If 25 grams of P4 and 50 grams of O2 reacted as shown in the following reaction, here's the reaction. What is the limiting reactant? What is the theoretical yield? So let's read the first step. When the amounts of more than one of the reactants are given in the problem, you have a limiting reactant problem. And look, you are given the masses of both P4 and O2. So that tells you that this is a limiting reactant problem. Okay, so if the amounts of more than one of the reactants are given in the problem, you have a limiting reactant problem. Then the next step says to convert the grams of each reactant to moles, then use the mole to mole ratio from the balanced equation to find the moles of desired product. The only product here is P4O10. Okay, so it's telling you to convert grams of reactant to moles of reactant, then from moles of reactant to go to moles of product here, and then from moles of product to grams of product. So these three steps, this one, and this one, these first three steps, these are actually mass to mass conversions, which we have done in 8.2. That asking you to start with the mass of the reactant and end with the mass of the product, but instead of just doing it once, you have to do it for each reactant. So start with 25 grams of P4 and end with grams of P4O10, and then do it again for oxygen. Start with 50 grams of O2 and then end with grams of P4O10. Okay, so let's set that up. 25 grams of P4, and then I will use a different color. I'll use blue. 50 grams of O2. Okay, we have to go to grams of P4O10 for both of them. This one we have to end with grams of P4O10, and this one we have to end with grams of P4O10. And you might be like, wait, why am I going to the same thing? Isn't it going to be the same answer? It's actually not going to be the same answer, because one of these reactants is going to give us a smaller number of products here, and that reactant will be the limiting reactant. So we are trying to identify which P4O2 will give us a smaller amount of P4O10. Okay, so let's convert grams of P4 into moles of P4. Then from moles of P4, I have to go to moles of P4O10. And then from moles of P4O10, I have to go to grams of P4O10. That's going to be 3 conversion factors, because remember, going from mass to mass is going to be 3 conversion factors. Doesn't matter what the scenario is, that is always going to stay constant. Okay, so I'll use orange to write my conversion factors on the top and the bottom. So the first thing I have to do is to figure out the molar mass of P4. Remember, whenever you go from mass of one substance to the mass of a second substance, the first conversion factor is always molar mass. So that is just the molar mass of phosphorus times 4. Okay, that's going to be 1 mole of P4 over 123.88 grams of P4. Where did I get the 123.88? It's phosphorus's molar mass 30.97 times by 4, because P4 has 4 phosphoruses. Okay, now let's look at the reaction to figure out the mole to mole ratio between P4O10 and P4. It's 1 mole of P4 for every 1 mole of P4O10. And I want P4 to cancel out. So 1 mole of P4 is going to be on the bottom. Okay. Then 1 mole of P4O10 is going to be on the top because P4O10 is where I'm going. Then the next thing I need is the molar mass of P4O10 or tetraphosphorus decoxide. So the molar mass of 4 phosphoruses and 10 oxygens added together is actually 283.88 grams P4O10, and on the bottom is going to be 1 mole of P4O10. Remember, molar mass is always accompanied by 1 mole. Now, let me cancel out the units that need cancelling. Grams of P4, grams of P4 cancel out. Moles of P4, moles of P4 cancel. Moles of P4O10 and moles of P4O10 cancel out. And I'm left with 25 grams divided by 123.88 times 1 divided by 1 times 283.88. That actually gives me 57.3 57.3 grams of P4O10. Okay, so from 25 grams of tetraphosphorus, the amount of tetraphosphorus decoxide that can be produced is 57.3 grams. Okay, now let me make this nice and fresh for the next calculation. I have to figure out how many grams of the product can be made from 50 grams of oxygen now. So 50 grams of O2. I'm trying to go from mass of O2 to mass of P4O10. So this is again a mass to mass conversion, just like this previous conversion. Okay, so let me use a darker blue. All right, so first we have to convert grams of oxygen to moles of oxygen. The molar mass of oxygen is 32 grams per mole. So 1 mole of O2 on the top, 32 grams of O2 on the bottom. So grams of O2 can cancel out. Now let's look at the comparison between these two. You have 5 moles of O2 for every 1 mole of P4O10. So 1 mole of P4O10 on the top, because that's the direction we're going. 5 moles of O2 on the bottom. Okay, then the molar mass of P4O10, we already calculated that for the previous question. 283.88 grams of P4O10 over 1 mole of P4O10. Okay, now let's cancel out the units that need to cancel out and then get the correct answer. Grams of O2 cancel out, moles of O2 cancel out, moles of P4O10 cancel out. 50 grams divided by 32 times 1 divided by 5 times 283.88 gives me 88.7 grams of P4O10. So look at that. Let me actually write it so that I have some space. 88.7 grams of P4 88.7 grams of P4O10 can be produced if I used the 50 grams of oxygen. Okay, so the reactant that is producing the smaller amount of P4O10 is the phosphorus, the P4. So the smaller amount of product is actually called the theoretical yield. So this is theoretically the maximum amount of product I can form if I react 25 grams of P4 and 50 grams of O2, because the 25 grams of P4 is limiting my reaction. So it's the limiting reactant. Okay, so we had to do both calculations in order to figure out which reactant, P4 or O2, will produce the smaller mass of product. The smaller mass of product, the numerical answer is my theoretical yield. Okay, so if I ask you what is the theoretical yield, which is this question, what is the theoretical yield? The theoretical yield is always a numerical answer. It's 57.3 grams of P4O10. And then if I ask you the question, what is the limiting reactant? What is the limiting reactant? The limiting reactant is P4. Okay, this is not a numerical answer, this is just the reactant name. Okay, the limiting reactant is P4 and the theoretical yield is 57.3 grams of the product. Okay, so those are the two questions. So you require two mass to mass conversions, converting each of the reactants to the product. So 25 grams of oxygen, I'm target 25 grams of P4 to the grams of P410, 50 grams of O2 to the grams of P410. Then you compare these two. 57.3 compared to 88.7 is the smaller amount. So the smaller amount is the theoretical yield. And then you backtrack. What's the reactant that produced that 57.3? It's P4. P4 is the limiting reactant. Okay, so check the reactant with the smallest answer is the limiting reactant. The answer is the theoretical.